Dr. Bibb Allen, one of our new gold medalists and ACR's Data Science Institute Chief Medical Officer, and Dr. Keith Dreyer, ACR's DSI Chief Science Officer, will present an Informatics and DSI report. Drs. Allen and Dreyer.
Well, good morning, and thank you for being here. Thank you, Tim and Rich. I am Bibb Allen, the DSI's Chief Medical Officer, with no commercial disclosures to disclose. I'm a member of the Birmingham Radiological Group, a community practice in Birmingham, and all of my stuff is on file. So as we started the Data Science Institute, and Geraldine said in her remarks on Sunday that educate, define, and lead. In the education arena, I want to point just one thing out importantly, and that is the multi-society ethics paper that has been in the comment period. Is going to be published in a shorter version in radiology and in JCR that gives the Data Science Institute now the ability to have a code of ethics. We wanted to define the beneficial uses of data science, which of course led to our initial work in creating AI use cases, and then finally to help radiologists become a leader in data science. And how we did that, where we looked at three important questions. What are the most important clinical tasks for AI? How do we make sure that AI is safe and validated for clinical use? And then how do we make sure it's working in the real world? And we leveraged three historical attributes of the college. Really, our resources around the appropriateness criteria is how we saw the ability to, it was the model for our use case panels to develop structured use cases for AI. We looked at our clinical trials experience and how do we validate this and how can we leverage that multi-center trial atmosphere into how we validate AI algorithms so we can make sure that they're safe for clinical practice. And then, of course, our registry program is how we're thinking we can monitor and make sure that AI is working in the real world. And if you look at our timeline of how we've done all of this, we've had numerous meetings with the FDA. We've set up numerous demonstration projects with both researchers at academic institutions and developers in the industry sphere to look at and validate these tools that we're making for clinical use. But now we've turned our attention to what do radiologists need for the future to adapt for AI. And this is going to be the purpose of what Keith is going to talk about in a minute, the AI lab. But basically, we believe this pyramid sort of describes learning the basics of AI, evaluate AI for use in your clinical practice. These are things that I think all radiologists, whether you're community practice or academic, whether you're a data scientist or just like me, a regular clinical guy trying to get the work done. But I think in the middle, there are going to be those of us who want to contribute to use case development, to be able to create annotated data sets that will help us participate in the validation of AI for clinical use. Or what to do when a developer comes calling and says, I want to use your data. I want you to mark up some cases for us to use. But at the tip of this pyramid, it's going to be those who are creating AI in our practices, and even some that want to take the step into the venture of going through the whole process to get it approved by the FDA. So with that, I'm going to turn it over to Keith to talk to you a little bit about the AI lab.
Thank you, Bibb, and thank you all. There's a demonstration of this that you can see up in the mezzanine by the coffee break area, so I'd please invite you to go up and take a look over the time that you have available. It'll take a few minutes, but also the goal of this is to make this available to you in your practices at home or on the plane home. So there's a mobile app that you can look at. You can just go to the website, ailab.acr.org. But let me just step you through this here. Like Bibb, I have minimal conflicts here, but they're all on file and exposed. So the goal here is to what we're calling democratize AI. The challenge that I've seen so far in this industry is that there's a lot of data that we all have behind firewalls that is difficult to move for obvious patient safety reasons. Data scientists are at various universities and companies, and then companies that want to try and put these solutions together don't have a lot of that data, and then there we are wanting to receive the solutions that they make, and we have the data, and we have the ability to request what it is we want, but all these actors are in different places. And so the goal is to actually create a framework for all of those groups to communicate. Similar to, and some of you may not know, but ACR was instrumental in the 80s for creating DICOM because we ran into this same problem back then, where trying to make PACS systems and reporting systems and EHRs or RISs at the time all communicate was very difficult without standards, and so those standards got created. This is the same thing we're doing for AI, but we're also putting a layer on top, an application layer, so you all can become familiar with what this technology is and actually start to use it. So that is the introduction of AI Lab as not only the framework, but an application on top of that to empower radiologists to easily implement, evaluate, and create AI. We want to have a component where you can actually learn pieces of this, and we'll talk about that. To define, which is, as Bib mentioned, these use cases. Now we want to crowdsource use cases so everyone can contribute and interact and edit. Evaluate, so you can run models that may be out, that are coming from vendors or that can be created by colleagues. You can create this yourself without having to code up like you do today, code up using Python or R or different code sources. Now you can just do this by selection, and you can see that up here, or I can show you here. And then finally, to be able to collaborate. So it's been a challenge for people to be able to share their data, as I mentioned, for moving it through the firewalls, but now you can create models at institution A, model at institution B, and then just share the models and not have to share the data, and you can get stronger, more robust algorithms. So we want to make that available for people to do as well. And again, this is not that we're entering into the software business. This is to create the platform so that industry can actually understand. Just like in DICOM, I make a printer, I make a monitor, I make a workstation, I make a storage system, the same kind of thing here. So we had a meeting last night with industry, about 50 members were there, folks were there, and we talked to them about this framework and got a lot of good feedback, and are continuously interacting with them. So let me just step you through this application real quick. It gives you these kind of functionalities and components, as I say, are exposed through this simple, straightforward application. So here's first is the home page. It guides you through some of the things that you can do. All the data right now is for mammography for breast density coming from the DEMIS trial, about 62,000 cases available for training. So it steps you into the different, just basically how to learn this. So it's just a couple-minute vignettes of exactly what it is that we mean by democratization, or what the modules are inside of here, or some of the details of how you build a model through this process. Here's an example of all the use cases that we've created, and you can go deeper into it and take a look. In this case is classifying suspicious microcalcifications, and this is the use case that's been constructed or could be constructed going forward for the other areas as well. This is Annotate, so it shows you how to create a data set for training or for testing or for evaluating. In this particular case, we let you go for breast density, as I say, and you can, on the right side here, select the grade of density and just keep continuing to annotate cases. This is kind of the rocket fuel that's necessary that you need to build artificial intelligence. Once you've done that, you could say, look at other people's models that they have and compare those. So you could say, I've created a data set to analyze 2 different companies' models, and I want to be able to test those out. Here's performance metrics, and now for the first time you can actually see how these algorithms compare back and forth to each other, because we're all going to be in the situation where we're trying to decide which vendor solution is best or most appropriate for our facilities, for our patients' data. If you want to go, as Bib's example of going up that pyramid, and you want to actually start to create some AI models with your data, you'll be able to actually define the problem, prepare the data, and configure the model. No programming. It's all done kind of underneath. And when you say, okay, I'm ready to test and train that, you can do that, and it comes back and says, here's your accuracy, here's the model, here's what's called a confusion matrix, and again, push a button and it gives you a video explanation of what these things are, so we can all become better versed. I think of this like a new modality. So for those of you that trained before MR came out, then MR came out and we all had to get up to speed on that. It's the same kind of thing here. We want to let everybody be familiar with what this technology is. Now in this case, I can just select run in that bottom right corner, and I can actually see the results of that AI running on data that I could have on premises. Finally, you can just run these algorithms on data. As I say, right now, all this data is from the cloud. It's from the DEMIS trial. The plan over the summer and into the fall is to allow you to do this on premises with your own data. We're also running challenges. And there's a challenge going on upstairs right now. You can do it, so I, again, suggest you go up there. You can win an iPad. But basically, it's to go through and annotate these cases just to get you familiar with the annotation process. And then finally, as I mentioned, if there's data sets being created at various places, you want the ability to share those with your colleagues and create an even more robust data AI model. The plan is to allow you to do that through this process, through the foundation, through either institutions, industry, or through these simple solutions that we have to let you create and combine those models to make them even stronger. As I mentioned, there is an iPad version, so you can go, iPhone version, you can go to the store, the App Store, and download that. And the goal here is, as I say, to take this through a development pathway. So if you wanted to actually create something and put it to commercialization, you can go through just like vendors do or partner with vendor to be able to put these things out into a commercial use through the FDA process that we have in place through a process called Certify AI and then Assess AI afterward. And the goal, as I say, is to allow this to be another one of the instruments that we all have to be able to use AI as appropriate, either developed by others and us to verify, or possibly even developed by ourselves for use inside of our own institutions. And just to mention, for those that are interested in more of this, we have a symposium that's running on October 5th and 6th of this year here in DC, where we'll go deeper into the use of all of this technology. And I'm sure it will have advanced quite a bit by then. 6 months in this field is like 100 years. So thank you very much.